Hello and welcome back to Mr. Abden's Mathematical Adventure. So today I just want to orient you to an idea. We started studying rational functions when you have some quantity, let's say like yay, but wait, it has to be divided up by another expression in x. Let's say x plus, let's do x squared plus 3x. So a polynomial divided by another polynomial, this is a rational function. But what we really want to focus on is the expression. So we don't even care that it is a function. We just have this expression. How can we manipulate this expression and rewrite it in a way that's more clear so we can understand it better? All right, one thing we can do is factor the top. So what adds up to 5, multiplies to 6, positive, positive. Okay, if you remember, it's not that these are positive that makes these, it's that when this is positive, these signs match. They might match as negatives or they might match as positive. But because they add up to positive 5, they must match as positives. Okay, and then it's 2 and 3. Okay, this is getting boring. Let's speed it up. Now we can factor out an x. There's an x in here and there's an x in there. We can bring it out to the front of the expression there. And you could rainbow that back in and you'd get x squared plus 3x, so we're good. But now we notice something. This quantity, x plus 3, is in the numerator and in the denominator. So when x is changing, let's say x is 10. This is 13, that's 13. We multiply by 13 on the top, divide by 13 on the bottom. That is 1. That quantity is 1. But what if x is 20? Then it's 23, divide by 23, which is 1. In other words, these two are perfectly balancing each other out and contributing nothing. Contributing times 1, which doesn't do anything. Except, what happens if x is negative 3? What is negative 3 plus 3? 0. What is 0 times negative 3 in this case? But 0 times anything is 0. Can you divide up some quantity into 0 pieces? No. There's no answer. That doesn't equal anything. So, x cannot be negative 3. But besides that one fact, these are not doing anything. It simplifies to 1 over 1. And so we can rewrite the expression as x plus 2 over x. But remember, x cannot be negative 3. So there's two answers to these questions. Now, you might also notice that x cannot be 0 right now. But a fellow mathematician can see that x cannot be 0. But they cannot see this fact because we got rid of that fact. So the obvious fact, x cannot be 0. Also, here's an invisible fact that we got rid of right here. Okay, so canceling things is great, makes things simpler, but it does technically remove a piece of information, and so we write that piece of information on the side. Let's do another example. Keep it interesting. What if we had 12 x to the 7th y to the 3rd divided by 3x squared y to the 7th? Can we simplify this? Yes. First of all, this quantity is 12 times bigger than this one. Oh, I misspoke. It's not 12 times bigger, it's only 4 times bigger because this quantity has this 3. So 12 would be 4 times bigger. In other words, we can actually divide this and get the 4. The 4 is on top and a 1 is down here. So these simplify to a 4. Let's put that here. 4. How's this looking? 4. How's the x's doing? We have 7 powers of x, and then we're dividing off 2 of them powers, so we have x to the 5th. We have 3 powers of y, but we're going to divide this quantity up. There's going to be more powers on the bottom, a total of y to the 4th remain on the bottom. If you're lost what's going on, think of y. This is y cubed is y times y times y. This is y times y times y times y times y times y times y. That divided by itself, 1. That divided by itself, 1. That divided by itself, 1. What's left? Y to the 4th on the bottom. Sorry, these aren't both true at the same time. This was replacing this stuff. Okay. There. This is simpler. But there is a fact that we destroyed right here when we got rid of these x's in the denominator. X cannot be 0. That's not obvious from our new simplified version. But if it flowed from the information in the top version, this fact is missing. But now we've put it back. So there you go. I think that should be enough. I'm going to post one other video about how to use big ideas, because frankly, if you use the, what is it called? The dynamic classroom, you can just go, the menu is the red menu on the left. It's annoying. Oh, I'm going to make a whole video about it. But you can go through, you can work through examples, you can check your work. You don't even need a teacher except for to tell jokes. So get on to big ideas, find the dynamic classroom, and go to town with the checking and the exploration and the learning. And I'll put up an assignment for 7.3. All right.